The Raspberry Pi, an affordable, low-power option that can be used in projects from robotics to networking to anything in between. But in today's video, we're going to be using this to create a backup NAS system using a couple of hard drives and Open Media Vault. Now, that in itself is pretty cool, but we do have a bonus feature. We're going solar, baby. Let's talk about it. That's right, we're going to be using a Raspberry Pi, a couple of hard drives, power of the sun, and a solar panel, as well as a battery system that I created, but that's outside and really heavy, and I'll get to that in a minute. But essentially what I wanted to do is create a net zero backup system that doesn't use any electricity from the grid at all. So this is a for fun project. This isn't really like, oh, a Raspberry Pi is so expensive to run, I just needed to run it off solar. No, I just had a bunch of solar panels laying around, don't ask me why, as well as a battery backup system that I built. Again, don't ask me why. And figured this would be a good use case. So we are going with a Raspberry Pi 4. This is a 4 gigabyte version. How I managed to snag this in this day and age when these are so hard to get, I don't know, but it was in stock on Pi Shop, I think is a website. And luckily enough, I got one. For storage, we are going with an external USB 3.0 connected docking station. So these are extremely common to find on Amazon or Newegg or wherever. It's just a simple external dock that houses two SATA drives. And the drives we are going with are two Seagate Exos 6 terabyte drives. So that gives us a total of 12 terabytes, math. And I figured that is just the best bang for the buck. So the dock itself, you can find them for around $30 to $50. The hard drives, depending on the capacity, will run you from $100 and can go up to about $500 if you're looking for high capacity drives. You can also go with other options. You can go with just simple external SSD enclosures. You can go with an external hardware RAID controller. This is the OWC Mercury Elite Pro Dual Mini. I just released a video on that the other day. Link is up here if you want to check that out. But this basically does hardware RAID on this device and then sends it over to the host device. You can run RAID 0, RAID 1. You can pass them through independently and do software RAID if you want. But there's a whole bunch of options out there. Just because I'm using this doesn't mean you have to. But for our purposes, yeah, that's what we'll be using. So the benefit of this is that you get higher capacity, but the downside is that hard drives draw more power. You could go with something like this, but it will be more expensive. It will use less power, but just know that the Raspberry Pi has a standard USB 3.0 interface, which I believe maxes out at 5 gigabits. So if you're expecting to throw in some really high capacity, high speed storage and get really blazing speeds, you're not. You're limited by the USB ports on the Raspberry Pi. So I think this is a good middle ground. But yeah, we will be going with Open Media Vault. It is a NAS-based operating system, and we are running a NAS, so that makes sense. You don't have to go with that. You can install whatever flavor of Linux you want and do it all manually. But I like Open Media Vault. It works well. It runs natively on the Pi, so that's what we went with. And honestly, it's really easy to install. I already did a stream where we got it installed on the Raspberry Pi. Link again is up here if you want to check that out. But yeah, that's all installed already. The only thing is to show you guys how I have the solar setup running. So let's take all of this outside and I will give you a little show of how we have this set up. Let's go. Okay, so this is the setup. And yeah, I know it's not the prettiest, but it's temporary. It's temporary, don't worry. So what you're looking at here is a custom built box. It's not pretty, duh, but I did find a use for all my LTT stickers. So that's good, I guess. But inside this box, it's just wooden, painted gray. Inside there, we have a Renogy 100 amp hour battery. It's a lithium ion one, so a good bit more expensive than a lead acid one. You can use whichever. There's benefits to lithium ion versus lead acid, but you're going to pay for it. So 100 amp hours in there at 12 volts. Also in there, we have our Renogy solar controller, which helps obviously charge the battery via solar. So I have one in there. It's a pretty cheap one. I think a 30 amp one, which is more than enough. I think it was like $30. And then we also have a 1000 watt inverter. So turning the 12 volt DC from the battery into 120 volt AC so that we can, plug in normal stuff in here. And the plugs we have on here, one you can see coming from the solar panel. That's the input to charge it. You can use whatever plug you want. I just converted the solar to a standard car cigarette lighter 12 volt plug. And that is the input. We also have outputs here, the 120 volt AC, as well as USB-C and USB-A output as well. So yeah, nothing too crazy. It's just input to the controller, controller to battery, battery to inverter, and cool. So you can see the solar panel behind me. I'm using a travel 100 watt panel. It folds up, it's portable. The reason I'm using that is because I've been testing this around different places to see what kind of input we could get from solar. And yeah, you can see over there, I have a more official, more proper 100 watt panel that is going to be much more efficient. But for the purposes of this, I'm going to use this to show you guys. So let's power it on and talk about it. So I've just powered it on. The battery is fully charged. The solar is connected. It's pointing directly at the sun. We have no clouds in the air today. So pretty much optimal scenario for this panel. And right now it looks like the hard drives are using about 20 watts and the Pi is using around 2. So you can see where all the power is coming from. So if you have more efficient drives, you're using solid state drives, you're going to draw less power, making this more efficient. So that's what I'm going with. 2 hard drives pulling about 20 watts. It does pull up to about like 50 to 60 on spin up just because more current to spin up disks. But over standard use, I've noticed that this entire system uses between 19 to 22 watts. So one benefit of this battery is that it's a smart battery, meaning I have an app to monitor it with a Bluetooth input. So let's unplug the solar for a second. And now we have no input. It's just running off the battery. And you'll see we're using about 2.18 amps at 12 volts. So you're looking at about 24, 25 watts, which is around what I expected. So now what we're gonna do is plug in the solar and see if we can offset that. All right, solar's plugged in and now we just shot up to 2.5 amps in the other direction. So we offset it by 5 amps, or that's 5 times 12, 60 watts. So that means a 100 watt panel is bringing in 60 watts, which is pretty good for a travel panel like that. If I were to use the fancy one, the actual made for outdoors and more efficient one, then we'd probably get around 80 to 90 watts, but I can't complain at 60 watts pulling in. So yeah, 60 watts in, using about 25. So we should never drain when the sun's out, but the sun's not always out, right? You guys are smart, you knew that. So how long will this last without any sun? So let's do some quick math. Now, 100 amp hours at 12 volts. We are running on 120 volts. So that's essentially 10 amps. So we get a total of 10 amp hours on this battery over 120 volts. Now let's convert that to watts. 10 amps, 120 volts, 1200 watts. The math's easy when everything's in tens. So we get 1200 total watts. Now remember, we said that this pulls around 20-ish watts. I'll use 25 watts just to play it safe. And let's do some quick math. 1,200 watts divided by 25 watts per hour. 48 hours. We get 2 full days out of this setup with 0 sun, which is pretty good. You're not supposed to drain any battery all the way down. Lithium ions are better. You can get down to about 20% before you start to degrade the life of it. Deep cycle batteries are worse. If you go anywhere under 50%, you can start hurting the battery's longevity. But we have lithium ion down to 20%. So let's say 40 hours. You get 40 total hours out of this with 0 sunlight. And remember, when the sun's out, we're charging this. It's not that we're just offsetting the power of it. we're actually charging the battery while powering the system. And everyone's setup is different. Yours might not be running at full power and pulling 25 watts all the time. If you're not using it for a while, the drives go to sleep and it's essentially pulling about 5 watts. So if this is just running some backups periodically, then it's going to last even longer. Now, I'm also going to show you a trick that I'm running to where it's going to use essentially no power during the day, because I'm using it as a backup system where it doesn't even have to be on during the day. So I'm gonna put this back in its home for now. This actually goes in the garage right here. The panel stays outside and the wire just runs in to power it. So this is out of the elements and I have an actual Ethernet connection. So let's put this back inside, plug it up, and get back and talk about some things. Okay, we're back and everything is set up and ready to go. Now, like I mentioned before, we are using Open Media Vault, so you're going to want to go ahead and get that installed. It's pretty straightforward. I've done a stream of getting it installed on a Raspberry Pi. I will link that up here. I can never get that right. But it's honestly really easy. There's a guide to do it. It's a couple of steps. The only thing I would suggest is to make sure that you install Raspberry Pi OS Lite version, because if you want to install Open Media Vault on top of that, it's not going to want to do it if you have a desktop environment. So make sure you use the Lite version. Now, once you have that installed, log into your Open Media Vault setup. I have done that here by accessing my IP address that we've set up before. I'm not going to go over the full installation. There's a lot of installation guides for Open Media Vault out there, but once you have it installed, come back to this point. So here we are in the dashboard. I don't have much running. This is a backup server. This is a backup of a backup server, so there's really not much going on. You'll see the CPU utilization is pretty low. We're not really doing much right now. Very little memory usage, and over here you can see our file systems. So first off, let's jump in and look at the disk setup. So going over here into disks, you'll see that here's our two 6 terabyte disks. Like I mentioned before, I'm going with two 6 terabyte hard drives. So nothing fancy, there's our disks. The next thing is to look at the file systems. Again, you can set this up however you want, whatever file system you want to go with, go ahead. I'm going with ext4. It's standard across Linux. It's easy to use. Both disks are set up using ext4. You can see they're online. They're pretty much mirror copies of each other. So to do that, it's really easy. You can just create one, go in here, assign a device. Now I've used both of my devices, so nothing's here. Then you can choose a file system that you want to use, click save, and it'll build it. You'll also notice that if I go into RAID management, there's nothing there because I'm not really using RAID, but I am kind of using a RAID setup. Let me explain. So if we go down here into shared folders, you'll see that I have quite a few shared folders. The two I want you to focus on right now are this Pi NAS and Pi NAS backup ones. So if we look at the Pi NAS one, you'll see it is on device SDA1 and it has a path of Pi NAS, and the Pi NAS backup is on SDB and has the relative path of Pi NAS backup. So essentially what I've done here is created a main shared folder on one disk and a similar shared folder on the opposite disk. And what we're going to do is essentially use disk 1 to write all of our data to, then have a scheduled RSYNC backup to take everything on disk 1 and move it to disk 2, or our Pi NAS backup shared folder. Now, why am I doing this? Basically because using standard RAID over USB is not generally the best thing to do, just because it's designed to work with direct SATA devices and direct access to the disks, and just the inconsistency of something like an external USB dock or something, it's not really the best environment for a standard RAID setup. So this is what I'm going with, and it seems to be working pretty well. So let's go over here and look at the RSYNC setup that I have set up. So we go over here into services, down to RSYNC, tasks, and RSYNC is a service that allows you to take data from a source location and output it to a destination location. So that could be a local machine to a remote machine, or a file system on a local machine to another file system on the same local device. So that's kind of what I've done here. So if we go into my one task and take a look at it, you'll see that our source shared folder is our Pi NAS shared folder, and our destination shared folder is the essentially the mirrored version in our Pi NAS backup shared folder. What that's doing is taking everything on disk 1 and migrating it over to disk 2. And I have that running at 5:05 every morning. You can have it run as frequently or as infrequently as you want. I have it running once a day very early in the morning because. And there's a whole bunch of settings. I'm not going to go through all of them. One that I turned on that wasn't on by default is this delete. And what that's going to do is say, if we've deleted something on disk 1, make sure to delete that on disk 2. So it's essentially going to be a mirrored copy. And that's kind of why I named it Pseudo-RAID 1 down here at the bottom, because that's kind of what it's doing. But how are we getting data from our system to the Pi NAS? Well, RSYNC again. So if I go and look at my Open Media Vault backup server, this is a completely separate device. It's also running RSYNC, but instead of doing a local to local sync, we're doing a local to remote sync. And when I say remote, I just mean another device on my LAN, not necessarily outside in the world. So keep that in mind. So in our backup server, similarly, we have a RSYNC task. And if we go in there and look at it, you'll see that it's running a push on a remote device. So it's taking everything on the local machine and pushing it to the Raspberry Pi. We've named a source shared folder. That's just what I've called it on my backup. And it's called SyncThing because initially I was going to use SyncThing, but decided to try RSYNC instead. In the destination server, it's going to follow this RSYNC protocol for entering a destination, and you enter the user, the IP address, and the name of the shared folder. So again, pretty straightforward. I'm using the Pi user. This is the IP of my Pi server, and that's the shared folder, Pi NAS. Authentication, you can set this up when you set up the RSYNC server on your destination. I set up a basic username and password, so that's what it's using here. Then when you want it to run, I'm running it at 3:05 in the morning, so it gives it 2 hours to copy everything over. Send an output, a bunch of options, the same thing, delete as well, and that is running. So I mentioned before that we need to set up the server on this side, so back into our Pi NAS, go over here to server and modules, and here just make sure that you take that shared folder and create a module out of it. So that's essentially what's taking the shared folder that you created in Open Media Vault and allowing it to be accessed remotely via RSYNC. So don't skip this step. And that's kind of the job of the Pi NAS. It just sits there, and at 3 a.m. and at 5 a.m., it kind of does its thing and takes data from my production and backup servers and makes sure to have another copy of that stored locally. And then once it has that, it copies it over to another disk on the Pi as well. So we have a lot of redundancy with our data within my home network. And the transfer speeds are pretty good on here. So I mentioned before that I had another shared folder, this Pi storage shared device, and I'm just using that as a Samba share to kind of take random files, test them, throw them on the Pi NAS, and just a way to access it outside of actually SSHing into the device. So I've set up an easy Samba share and I have access to it right here. Here you can see we have it open. Now let's go ahead and transfer a large video clip from one of my previous videos. And you can see immediately it's sitting at around 100 megabytes per second, which essentially is saturating that 1 gigabit connection. Yeah, that's pretty solid. I mean, you honestly can't expect more out of a Raspberry Pi connected over LAN. This is pretty impressive. Now, yes, this is over a gigabit connection, so we could theoretically get more out of that 5 gigabit per second USB port, but I mean, 5 gigabits is what? Like around 600-ish megabytes per second. So if you're expecting to plug in some super fast SD storage like this, I mean, you'll get up to 600 megabytes per second, but you're not going to be getting these crazy speeds that you're expecting if connected directly over SATA or something, or even an even faster USB Gen 3.1 or USB 3.1 Gen 2 connection. So temper your expectations. Okay, the last thing I want to go over is that I did mention before that I have a setup where the Pi can actually just go to sleep and not be on during the day when I don't need it, and then wake up right before it needs to do all of its syncing and all that good stuff. So the way I've done this is by using a plugin called AutoShutdown. If you want to install it, go into System, go to Plugins, search for AutoShutdown. Once you install it, it'll be listed here in your services, and go and click on that. And what this does is essentially says, after an X amount of time of no activity on the device, shut it down, and then you also have the option to wake it up at a specific time. So that's what I've done. Go ahead and enabled it, and I've set it to 6 cycles and 300 seconds between cycles, so 5 minutes. And after 6 cycles of 5 minutes of no real activity on the system, it'll go into hibernate mode. Now you can set it to do whatever mode you want it to go into. Hibernate works for me. Then you have the option of doing a forced uptime with an automatic wake, which is what I have here. So I have forced uptime begin at 2:50 a.m. because remember, our sync starts at 3:05. So 2:50 gives it 15 minutes to warm up. It doesn't take that long, but just in case. And then it ends at 5:15. So no matter what, it will be on from 2:50 to 5:15. And remember that the sync starts at 5:05. So it'll do all of its stuff that it needs to do. And then with 30 minutes of inactivity after that, it will turn off. But this just makes sure that it's at least on for that sync. Then you go over here and set the wake alarm. And I've set this to use the forced uptime begin time. So that just means that when it's in hibernate mode, or if it's turned off, it will automatically wake up at the forced uptime begin hour, which is 2:50. Then there's a whole lot more settings in here. You can adjust the rate that it looks for hard drive and network activity. So if it's doing over 400 kilobytes in disk activity, then don't turn it off. That just means when it's cycling to look for an activity, if it sees something like this, the cycle starts over. So you can have this as high or as low as you want, depending on what your network activity or your disk activity is expected to be. You can set active processes that it looks for. There's settings in here of what to look for, SMB, users logged in, smart tests, plugins, all that good stuff. And essentially that's it. Hit save, and now your system will turn off and on based on the parameters you set, saving you a lot of energy. And especially when you're powering it over solar, this comes in handy a lot. But again, it's your use case. If you have your Pi running services that need to be running 24/7, you're obviously not going to use something like this. But in my case, there's a small window during the day where it runs. And then for the rest of the, 18 hours or so, it doesn't need to be doing anything. So it may as well be off, saving power. Another thing to note is that we do have smart access directly to both of the drives in here. So if we go in and look at our smart settings, you can see both drives are listed, both have a status of good. You can run tasks on here to check the smart statuses of these disks. That's something I wanted to note. Some people have asked, do you have smart access to these disks directly over USB? And in this case, yes, I do. So depending on how you want to use it, there you go. So that's it. That is my solar powered Raspberry Pi backup NAS system running Open Media Vault. And I'm honestly really happy with it. I'm happy with the performance we're getting out of the Pi, with the capacity we have, as well as the power efficiency, not only when it's on and running, but the fact that we can turn it off using the AutoShutdown plugin just makes it that much easier. So is this something I would recommend? I guess so. It just depends on your situation. Now, if you have access to a place where you can put a solar panel and you can run networking over to that location, and you have access to the sun, sure, go for it. Just know that there is a cost investment to this. The solar panel isn't free. The battery, the inverter, the charge controller, none of that is free. You're going to have to pay for it. So in total, I probably spent around $600 or so on it. Now, you don't have to buy a 100 amp hour lithium battery, which was $400 in itself. You could go with something much cheaper. You could go with a smaller inverter. You can even go with a smaller solar panel if you want. So it's extremely flexible. But all in all, it's pretty cool. And that's essentially why I did it. I did it because it's cool, not because I just don't want to pay for the electricity for a Raspberry Pi. It's really not that expensive to run. I did it because it was fun. And that's honestly as good of a reason as you need to do something, honestly. So if you have people saying, well, you shouldn't have done this. This way is the most efficient. You know, why did you do it this way? Just tell them you did it for fun. And that's all that matters. So that's all I have for you today. I hope this video was entertaining. I hope it was interesting. I hope you learned something in the process. Let me know down in the comments if you have any solar setups in your home setup, or if you're interested in doing any solar projects. Let me know down in the comments. But that's it. If you like this video, be sure to drop a like below. If you like content like this, please consider subscribing. Thank you so much for watching, and I will see you in the next one.